Hello everyone, welcome back to my channel Skill Up Tutorials, one lesson at a time. In today's video, I am going to explain about queue. Queue is a linear data structure which follows FIFO principle. FIFO means first in, first out. Let's see an example to understand it more. This is the ticket counter. For example, if we see in movie theaters, we can see the ticket checker will be here and this is the counter and the persons will make a line and this is the first person who enters into the queue and he will get the ticket first. So this is the second person to enter into the queue. He will get the ticket in the second, and this is third person and this is the newest person. In DSA concept for queue, we call this first person as front and this is the last person there. That means the first entered person will known as front and mm, front is also known as head and the last entered new element is known as rear. So like this queue data structure will be there. And now let's go to the next slide. And there are some basic terminology used in queue. Those are front and rear. Front means this is the entered element, first entered element, and position of the entered element in a queue ready to be served. And it is also referred as head. We can also call it as head. And the first entered element will be removed from the queue first. This is the first entered element, and if we want to remove the element from the queue, this is the one which will be removed first. And then what is meant by rare? Rare means the newest entered element is called as rare. And as you can see here, this is the front and this is the rear. Always the front will be in the starting position and rear will be also there here. And as we add elements, rear will be increased. If we delete the elements, front value will also be moves like this. For example, let's check here front value is 1, I mean 0 index. And if I want to remove this element, then front value will move to here. So, and if I want to add this number, the rear value will move to here. And now let's go further so that you will understand it more. Now let's see some operations can be performed in queue. Those are NQ, DQ, peak or front, is empty. NQ means like adding elements into the queue. Then what is meant by DQ? DQ means removing elements from the queue. Then peak or front means peak means as we all know that the first entered element in the queue will be front and I will show so that you will understand it more. And is empty or not, we can check whether the queue is empty or not. If we move further, you will understand. Now let's see the first operation NQ. Now let's say this is the empty queue and first we will take as front and rear as -1 and the capacity of queue is 4. Okay. And here I am adding an element into the queue because this is NQ operation and I added element to this. So the rear value and front value will become 0. First the front value will be 0 in the starting and the rear value will increase the value while entering the value. That means 10 is entered, no? So rear value is increased. Front value will become 0 only. For example, let's take one more element and insert it. Here I inserted 20 element. Here you can observe one thing. Front value will not be changed. This is like head. Head will not change until you remove that value. If you remove this value, front will goes to here. Okay. Here I am adding a number into the queue. So 20 is added. So rear value is increased by 1. And I added one more element that is 30. So rear value increased to, as you can see, front value remains same. And I will add one more value. So rear value will become 3. Okay. Next, DQ operation. DQ operation means deleting the elements. Always the queue, as we all know, that the element will be removed from the starting. That means first entered element will be removed first. So 10 value should be removed. Then front value becomes 1. Okay, now let's see. Front value becomes 1, 10 was removed. We don't need to remove the value. We just increment the number, that means front value, so that this value will be automatically goes. And here I remove 20. That means I incremented front value. Okay. And I remove 30 also. So front value is incremented. Now you can see here front and rear becomes 3. Okay. Here I removed this one also, 40 element also. Then what happens? Front and rear becomes empty. That means Q becomes empty. Here you may get one doubt. You said, if I want to remove a value, then front value will be incremented. So here 40 value is deleted. Then what happens? Like front value, if I increment the front value, there is no fourth index. Then this is the problem of simple queue. That means disadvantage of simple queue. So we have one more queue, that is circular queue. Circular queue means the front value will goes to here. That means front value becomes 0. So if you want to remove any element, it will check whether it is empty or not. If it is not empty, it will remove. So not to go like any error, we mostly use circular queue. So this is the main disadvantage of simple queue. Now let's go to the execution so that you will understand it more. Okay, now let's say firstly, let's take a class. I'm naming it as Q. And now let's say I'm taking private numbers, that is int, friend, rare, and then size. And now let's take private int capacity. Capacity is like how many elements should be there in the queue. And now let's take the queue. Here I am explaining implementation using arrays. So I am taking an array. Now let's say Q. And now let's take the constructor to initialize the values. Constructor Q. And I want to take the capacity, so I am naming it as capacity. And now let's write this dot capacity equal to capacity. So many people will be having a doubt like what is this capacity and what is this capacity. This capacity is like coming from the caller, that is coming from other side, and this capacity is like the class member. This is this class member. So to differentiate and to understand for the compiler, so we need to write like this. And now let's initialize the array. Let's take Q, like small letters, right? Q equal to new int of, this is how we initialize the array. And capacity, we know the capacity, no, so I am mentioning it. And as I said before, front value will be 0 and their value will be -1 and then size will be 0. Here you may get one doubt, that is like what is meant by size and what is meant by capacity. Here we already have capacity, no? Then why you are taking size? Capacity is like capacity means size of the cube, like how many elements we can insert, so that is capacity. Then what is meant by size? How many elements are there in the cube? So for example, firstly we will be having 4 elements. If I delete one element, then how many elements will be there? 3. So that is size. Total capacity will be 4. So that is the difference between size and capacity. We move further, so you will understand why we need to take this size. And now let's check whether the queue is empty or not. How can we check? Like public, I need to return true or false. So I'm taking this is full. I'm checking whether it is full or not. How can we say that full or not? This is simple. Like how many elements are there will be known by this size, and capacity will be this. If these both are equal, then we can say that Q is full. So if size equal to capacity, it will return true. That means if these two are equal, then it returns true. That means it is full. If it is not equal, then it returns false. Then it is not full. Okay, this is how this is very easy. And now let's try whether it is empty or not. Public Boolean. I missed somewhere here. And is empty or not. Now let's try this. And how can we say if it is empty or not? If written with size equal to 0. As I said before, size 0 means no elements was there. So we can use this. And now let's write the actual NQ operation. NQ operation. Okay, now let's take a public and then void. I don't want to return anything. And let's write NQ. And I want a value to be inserted. So I'm writing as int item. And then now let's say, now this first we need to check whether it is full or not. If it is full, we cannot move further. So if of is full, as I said before, it will return true or false. If it is true, it comes inside, then we can return -1. If it is not true, you may get wondered why written -1. You can add else, or you can add not is full. You can add, but if we want to, that means, how can I say? If you want to handle exceptions, then this is very useful. You don't get any error, and your exception will be solved very easily. So for that purpose, I am writing this. And if it is not true, then what we need to do? Now let's say. mm, I wanted to print like they are asking to enter some element. So if we are not entering any element, so the user should know the queue is full, so we are not entering the element. So queue is full. And now let's go to the execution real part. And what they given, rare equal to rare plus 1. Here I'm not entering. Rare equal to rare plus 1. Mod capacity. I will explain this so that you will understand it more. Now let's say, as we all know that if we want to enter any value, so okay, now let's see this so that you will understand it more. And if you want to enter any value like this, you will do. For example, let's see, for example, and here as you can see, I wanted to enter one more value, but I don't have, if I increment the rare value, then here nothing was there. So, but the queue was empty. I want to enter value. So here comes circular queue. So here I am using rare first. I am incrementing the value. That means 3 plus 1, 4. Then 4 mod capacity. 4 mod 4 means what? 0. So then here the rare value comes to here. So the value will be inserted here. So for that we are using like this. That is the reason we add it like this. Okay, I hope you understand this. And next we need to like queue item, sorry, Q rare equal to item. So this is how we can add element into the queue. And we need to increment the size. Size means how many elements will be there in the queue. So to know the size value, we need to increment. So one value is entered, so size becomes 1. So, and I will print system dot out dot println of item, and now let's say mm, enqueued. Okay, then this is how we will write the enqueue method. And now let's go for the dequeue method. Public and int. I want to return this value. So dequeue, and then I will check first whether it is empty or not. If it is empty, we cannot delete any value. So is empty. And if it is empty, I will display the queue is empty. You cannot delete. So return -1. And if it is not empty, then let's take, I am returning the value, so I am taking this. As we all know that the front element will be removed first. So what we need to do is queue of front. So that's it. It is very easy. And as I said before, just we need to increment the front value. So to increment the front value, front equal to front plus 1. This is same as like before, and I will explain this also. Plus mod capacity. That's it. And we need to increment the size value because size will tell the how many elements in the queue. So if we decrement the value, so the value will be changed in size also. So I am returning the value. Now let's see why we return this statement. Front equal to front plus 1 mod capacity. Now let's go to the slide so that you will understand more. And now let's say the front value becomes 3 and rear value becomes 3. This value also deleted and we added new values. Some new values are added into the queue. Let's say, as we all know that another element 50 is added here. Then if I want to remove the value, then how can I remove? As I said before, if you increment the front value, automatically that value will be removed. Already the front value is 3. If I increment front value will becomes 4. Then this value will not be removed from the queue. So here comes circular queue as same as like NQ function. So front becomes 4, front plus 1 4 and 4 mod capacity. 4 mod 4 is 0. So it comes to here and this value will be removed. So this is how I return this statement. This is same as like NQ operation. Now let's write the code for peak method, that is public. I want to return this also peak, and now let's say they just asked for display the peak value. So I want to display it. Mm, So what you can do is first you need to check if it is empty or not. Is empty. We are just calling that method and we are checking if it is empty or not. Like if it is empty, display it. System dot out dot println of q is empty. This looks like a long code, but this is very simple if you understand the concept. So, and if it is not empty, then we can display. How can we display the peak value? Like displaying the front value. So, out dot println of just display the front value. So this is fine. And but we written here int. So let's return this. So it would be better. Mm, just write return and keep semicolon. That's it. So and now let's write the method for displaying the values. What are the values present in it? And public void. I'm just displaying it. I'm not returning anything. So display of and now let's write the code. Let's first we need to check if it is empty or not. Is empty. If it is empty, just print system dot out dot println of q is empty. And now let's return. If you don't write the return statement, then remaining statements also will be executed. So now let's write system dot out dot println of q is just for understanding purpose that I am displaying the values. So for int I equal to 0 and I less than size. Size means as you all know that how many elements present in the queue. Okay. So I am displaying this system dot out dot println of queue of front. We need to display the front value and same as like before, we need to use the circular queue so that we don't get any error. And here you need to add I value because this is I value 0, 1, 2, 3 so that this will be executed and we will get the perfect result. Capacity same as like before, but here we are adding I in place of 1. So let's keep some space so it will be easy for understanding. And system dot out dot println and I'm adding a new line here. And now let's write the main method public. As you can see here, I'm writing the main method in the same class and I'm using the private members. So this can be accessed in this class. Public static void main syntax. And then now let's create the object for this class q. Q equal to let's say q of I'm adding 4. Okay. Now let's see q of and q of. Please take care about spellings. And q of I am adding 10 value. And now let's say I will add 4 elements like so you will get to know what is happening. If I try to add one more. Okay, now let's see up to here. Now let's see the output. As you can see, 10 is queued, 20 is queued, 30 is queued, 40 is queued. Now let's try to add one more element. Now let's see what we will get. And then, yes, queue is full. We are getting like this. And I will remove the elements. Now let's see what happens. Let's say q dot dq. We are not sending any value. Okay, now let's see what happens. Here I think I did not add. Okay, this is returning one value, I think. So Let's take int k equal to dq, or else you can just print it. System dot out dot println. So this is returning one value, so we are printing this. And now let's run this. As you can see, 10 value is written. That means 10 value is removed. First entered value is 10 and 10 value is removed. And now let's call the display method. So we will understand how many elements are there. Display. Okay, now let's run this. Wait, let me check. I need to use q dot. So q dot display. Now let's run this. As you can see, 10 is removed, 20, 30 and 40 are there. Now let's try to remove some more elements. Like I will remove remaining all. 2, 3. I will adjust these. So I removed 4 elements. Now let's try to display this. So let's see what we will get. And now let's run this. And after displaying 20, 30, 40, 20 is removed, 30 is removed, 40 is removed, and Q becomes empty if I display this. Now let's try to delete one more element. Now let's see what we will get. Let's run this. We should get the Q is empty. So you cannot return any value. Okay, now let's remove this, and now let's print the peak value. Out dot println of Q dot peak method. I'm just calling. And now let's run this. Because the elements are empty, so I think we don't get anything. Q is empty. Now let's remove these two. And now let's see. Yeah, 30, 40, these two elements are there. As you can see, 30 value is printed. This is the first entered element before this 40. So this is how this will be executed. I hope you understand about DQ implementation using arrays and simple queue and circular queue. If you have any queries, please comment below. Please do like, share and subscribe to my channel. Thank you.